In my previous videos, I have already discussed how to find the basic feasible solution by northwest corner rule, matrix minimum method, and Vogel's approximation method, that is BAM method. And also, I have already discussed how to optimize a transportation problem by applying MODI techniques. MODI means modified distribution method. Today, I am going to discuss the maximization problem in transportation case. That means I have to discuss the maximization problem. Previously, I discussed the minimization problem. The normal problem of transportation is minimization, because in that case, we have to minimize the transportation cost. But today I will discuss a special problem which is not cost. In place of cost, you will get the profit data. And for that reason, we always maximize the profit. We'll try to maximize the profit. That's why it is a maximization problem in the case of transportation problem. I am briefing first the transportation problem in this case. So these are the production centers, or you can say factories. These are the factories where the product are being produced. Factories, right? Yes, factories A, B, C. Okay, the capacity of the factory is 1000 units. For factory B, the capacity is 700 units, and for factory C, the capacity is 900 units. And these are the marketing places. 4 marketing places, you can say Bombay, Delhi, Calcutta, Nepal, like that. And or you may call it as dealers also. Now, instead of cost, here the profit data are given. That means if you produce the product in this production center and shipped to this dealer or marketplace and sell in the market, you will get profit per unit rupees 6 in this way. And suppose I am explaining this one. Suppose you are producing the product in factory B and shifting to the dealer, to the marketplace of 2, and selling in the market. The profit per unit will be rupees 2. In this way, the profit figures per unit relating to factories and marketplace is given. Last I'm explaining another also, say 7. This means the product is being produced in factory C and is being sold to marketplace C, and then the profit per unit is rupees 7. In this way, in place of cost, the profit figures are given. So what we have to do, we have to maximize this problem in such a way. I have to determine from which source how much quantity if you shift to the selling point or dealers, so that the total profit will be maximized. That is our problem. Okay. Now I'm going to solve it. The first of all, what you have to do, the first step in this case, as it is a maximization problem, you have to convert the maximization problem to minimization problem first. How we'll do it, I'm not going to discuss in detail the mathematical jargon. Simply, what you will do to convert this profit problem to cost problem or minimization problem, you select the maximum profit per unit. In this case, out of 6, 4, 5, 6, 8 is the maximum profit per unit. And you subtract all the elements of the matrix with that maximum element. Then what will happen? Instead of profit, it will be converted to loss. And it is called opportunity loss, you can say. Now, minimization of loss is equivalent to maximization of profit. That's why your first task is you find out the maximum element out of the given elements, profit elements, and then subtract all the elements from that maximum elements. In this case, I'm noting here the maximum elements is 8. I have to subtract all the elements from that element and prepare a new matrix. To save the space, I am doing this steps in the same matrix itself. How? First say subtract 6. This is the profit per unit from 8. Then how will you get? What you will get? Then you will get 2. I am writing in the same matrix, but you will do in the separate matrix. To just save the space, I am doing this. From this also, you subtract 6 from 8. That is 2. This is again 2. 2. And what it will be? 8 minus 4, that is 4. Then again 8 minus 4, that is 4. And this is 8 minus 2, that is 6. 8 minus 4, again it is 4. 8 minus 5, that means it is 3. Now 8 minus 5, that means it is 3, and 8 minus 6, it will be 2. 8 minus 7, it will be 1, and 8 minus 8 is 0. So in this way, you will convert the maximization problem to minimization problem, because all these are the opportunity cost. You have to minimize the cost. It will automatically profit will be maximized. Now, as usual, as I have already done in my previous problems, I am going to solve this minimization problem. Now this has become the minimization transportation problem. Okay. Achha. So this problem will be solved in 2 steps. First, to find out the basic feasible solution, and then you have to optimize it by model. Here I am going to apply, say, matrix minima method. I am going to solve this problem by applying matrix minima method to find out the basic feasible solution. There are 3 methods: northwest corner rule, matrix minima, and also BAM method. But one problem I have already discussed through BAM. That's why I am going to discuss the matrix minima method. But you can apply any one, because that is the starting point only, not the best one or optimized one. You have to optimize by applying model. That is the second step. So first I am going to find out the basic feasible solution by matrix minima method. As I have already mentioned, to start, to find out the basic feasible solution, you always check it is a balanced problem or not. Balance means the total availability, the availability of the factory, the production units, that is 22,600 units. If you add this plus this plus this is the total available units. Will be is equal to the requirements or not. Requirements for this center is 900, 800, 500, and if you add, in this case, it is again 2,600. That means it is a balanced problem. If it is not balanced problem, that problem I also have discussed earlier. It is called unbalanced problem. In the case of unbalanced problem, you have to add dummy source or dummy requirement as per requirement, and to make the transportation problem a balanced problem, and only then you can proceed further for finding out the basic feasible solution. Here we need not to do anything, as it is already a balanced problem, because if you add all this, then you will get this is 2,600 units, and the requirement is also 2,000 units. Okay. Now I am going to start the matrix minima method to find out the basic feasible solution. As usual, as I have already discussed, for the matrix minima method, must find what is the lowest cost out of all these costs. Now this is cost, not profit. The lowest is 0, and for that you allocate in this cell. You allocate in this. The allocation rule is same. I am not again discussing detail to save the time. I have already discussed 2-3 problems. The allocation will be 400, because out of these 2, the minimum one we have to allocate here. The reason I have already discussed. Then the demand or requirement left is 0, because full have been shifted, and the availability remains is 500. As the requirements have been fulfilled for this marketplace or dealer, there is no scope for shifting any unit to these cells. That's why I have blocked it. So that mistakenly I should not put any allocation. Next minimum cost. You go to the next minimum cost. Where is the next minimum? 1 is the maximum. Then you have to allocate here. How much you will allocate? 500 and 500. The minimum is, in this case, both are same. That's why I am going to put 500 units. The requirement is 0 left, and production is also left 0. As it is 0, that's why you cannot move further or put any allocation further. Here is also 0. That's why you should block it, so that mistakenly you should not allocate any further units here. If you put here mistakenly, then the total amount will be increased from the available units. Now, next lowest cost. Which one is the next lowest cost? 2, 2, 4, 6. Out of the lowest cost of this, 2 is the lowest cost. That means you have to allocate. They have 2 cells are cost 2. Which one you will take? It is a convention. Generally, we will consider that lowest cost, where the allocation will be the topmost upper row and at the same time topmost lower column. In that case, the topmost row is this. This is same again. Again, this is same top row, same row. Then the lowest column, 1, 2, the lowest column is this 1 column. This is 2 column. That's why it is advisable to allocate in this cell. You make it as a common rule always. In this way, you will allocate. If the same, then you will consider the upper row and lowest or lower column. How much you will allocate? 900 and 1000. The minimum one you will put. It's 900. 0 and if you put 900 here, then the balance availability is 100 and the requirement is 0. As the requirement has been fulfilled, you need not to allocate further in this cell. As only one column is remaining, that's why you can put directly, no problem. But considering the cost also you can put first. We are considering the lowest cost too. That means the allocation will be 800 and 100. The lowest one is 100. That's why we're going to put 100. That is 0 and this is 700 and this is the last cell, 700 and 700. It will be definitely match, as we have already checked. This is a balanced transportation problem, means total availability and total requirement is same. So the finding out the basic feasible solution by matrix minima method has been completed. These are the basic allocations. That means one is from A to dealer 1 you have to ship 900, and from A to dealer 2 you will ship 100 in this way. And from 500 means from factory C to dealer 3 you have to ship 500, and you can check this is already same. 500 plus 400 900, that means 700 and 1000. In this way it is checked that the total availability and total requirements have been fulfilled. Now we have to move for the second step. What is the total cost for this allocation? That is better to note down, because in future you will see after applying the optimization technique body, the cost will be either same or will be decreased. Okay, that's why I am going to note down in 900 plus 2 plus 100. In this, for this allocation, the total transportation cost will be this, plus 700 into 6 plus 500 into 1 and 400 into 0. 400 into 0. And how much it will be? Just check it. How much it will be? So 1800 plus 200 plus 706, 4200, so it will be at least, and 500. This, that is total 6700. 6700. This is the value. Okay. Now I am going to discuss the MODI method. Just to save the space, I am erasing all this because that will not required for the next step, and same matrix we will use for applying MODI. And I am noting down the total cost for this initial basic feasible solution as 6700. 6700. I am erasing all this. 6700. First transportation cost 6700. To check that the after applying MODI, the cost will be reduced or at least same. I am erasing all this because these are not required to apply MODI. Okay. This is the basic allocation matrix. Now I have to apply MODI. How will apply? I have already discussed. I am erasing also this. Just these are the basic allocations. Okay. Achha. To apply the MODI method, first of all, you must check whether the number of allocations is equal to m plus n minus 1. Is equal to, in this case, m means row, number of row is 3, and number of column n is 4. 1, 2, 3, 4 minus 1, that is 6. 6 number of allocations are required. 6 number of allocations are required to start MODI. To start the next step of MODI. How many allocations are here? 1, 2, 3, 4, 5, which is less than 6. That means you cannot move further. You cannot apply MODI. Then what you will do to make the number of allocations at least 6, what you have to do? You have to artificially allocate very negligible quantity to a cell to make the total number as 6. I am putting here, say this is that item number, epsilon number of units, or this is I have to put to make the number of allocations 6. Now 1, 2, 3, 4, 5, 6. And the epsilon is a very small quantity. If it is say in kg, then the magnitude of value of E or quantity E is say milligram of kg. Okay? In that, which has no effect virtually to the cost in that way. And where you will put epsilon? Here you will put epsilon? No, it is not allowed. That means you have to put this epsilon or the artificial quantity for mathematical purpose in such a way any square should not form. In this case, if you put here, then square will form. It is not allowed. That's why I have not put here. Is it allowed to put here? Suppose it is not there, not to put only one. Then if you, is it allowed? Yes, it is allowed. This is not here. One, there is no square. There is no square. That's why it is allowed. But I am taking here. It is allowed. Yes, here is also allowed. In this case, here is also is not forming square. Only you will check that allocation should not be in such a way that a square is formed. In this case, this is not allowed. Otherwise, you can put in any other cell. You can check no square will be formed. Okay. Why I have written here? You try to put this variable value in such a way so that the number of allocations will be more, and that will be an advantage for you. How advantage that I will show you. You can put here. That is also 3. No problem. You can check by putting there. I am showing only 1. Okay. So now the total number of allocations is 6. So artificially, for the mathematical purpose, you have to put a negligible quantity to any cell so that square should not form. And now the total number of allocation is 6. That's why you can proceed for body. Now I am putting to solve this problem directly. I am going to show you the direct method how you can do it. And if you want to form the equations, that also I will give the hints there. But you see my previous problem where I have shown in detail forming the equations. But to save the time, I am using direct method. Now 0, this is actually the dual variables ui and vj. Ui means u1 plus u2 and u3, and v1 plus v1, v2, v3 and v4. All these are called dual variables. The basic cell's cost is to be divided into 2 values, that is u and v. That is called dual variables. Now if you put 0 here, then you can write directly 2. This is the advantage, 2 and 2. So why 2 and 2 and 2 you are writing? Because the consideration is if you add this cost, then you will get this cost. You have to divide this cost in 2 parts so that if you add these values, you will get this value. Now, as it is 0, that's why you can put directly 0 plus 2 is 2, 0 plus 2 again it is 2 in this way. For all the non-basic cells, you have to find out this u and v, and you have got these values only. Which values left? You have to find out these values, the dual value, with the help of basic cells. You have to find out all the variables. Still you have to find out this value. Still you have to find out this value with the help of basic cells. How you will find out? I am showing for this. This is the basic cell. You can take the help of this, because with the help of this basic cell means where the basic allocation is there. This is non-basic cells. Here no allocation is available. So with the help of this, you can find out this variable. How? 6 minus 2. 6 minus 2 is equal to 4. That means 4 plus 2 is equal to 6. So as it is to be added, that's why it is better to find out the left one. What you will do, you will subtract the other cost from the cost of the basic cell. 6 minus 2 is 4. Then what will be this value? Where you will take the, where you will find out this value? This is the basic cell. It is available. 1 minus 2. 1 minus 2. Then you will get this value. 1 minus 2 means minus 1. Then you can check 2 plus 2. 2 plus minus 1 is 1 in this way. Still you have to find out this value. How you find out? 0 minus this. 0 minus this means plus 1. 0 minus this means plus 1. That means if you add this, you will get 0. In this way, you can find out all the dual variables u and v. Actually, the concept behind is you have to form the equations with the help of the cost of basic cells. So I am writing set 2. The equation will be, in this case for 2, u1 plus v3. u1 plus v3 is equal to 2. Then for u1 plus v2, u1 plus v2 is equal to again 2. In this way, you can write the equations. How many equations you will get? 6 equations you will get. But how many variables are here? 7 variables, because 4 columns and 3 rows. So you have 6 equations, but you have to find out the 7 variables. That's why the solution will not be unique. You have to put, at least you have to put one variable is equal to 0. Only you can, in that case, you can find out other way. That's why you have put one variable u1 is equal to 0. If you put u1 is equal to 0, then u1 is equal to 0, then v3 is equal to 2. In this way, if you put in all the equations, you will get these values. How you have done? For that, you please check my previous video where I have already showed there the detailed calculations forming the equations. But here, just to save the time, I have done it directly. How the directly you have to do that also I have done there in my previous video. Here also I am doing that. Now the next step, what you will do? The next step is you have to find out. The next step is you have to find out the ui plus vj for all the non-basic cells. These are the non-basic cells. No basic allocations. That's why all these are the non-basic cells. And circles means here ui plus vj. All non-basic cells, you have to put the ui plus vj. So what quantity you will write? What value you will write here? 1 plus 0. 1 plus 0 means plus 1 you will write here. What quantity you will write here? What value you will write here? 4 plus 1 means 5. 4 plus 1. Actually, this is ui plus vj is u2 plus v4. 5 in this way. What quantity value you will write here? 2 plus 4. 6 you will write here. And what value you will write here? 2 plus 4. That is 6. And what value you write here? 2 plus minus 1 plus 1. And what value you write here? 2 plus minus 1 means plus 1. You can check it again. 1 means plus 1. This plus this, row and column plus 1. For this, 4 plus 1, 5. This is 4 plus 2, 6. This is minus 1 plus 2. That's why plus 1. And 3 minus 1. Sorry. In this case, 2 minus 1 is plus 1. In this is 2 minus 1 plus 1. And this is 6 base, 2 plus 4, 6. The evaluation of ui plus vj for all non-basic cells have been completed. Now, finally, you have to find out the net evaluations. That's why you have to, for all the non-basic cells. I am not going to discuss the detail of resins. Here I am just going to discuss how we solve the problem. So what is the concept of triangle? The value you have to put here is, say, z is equal to Cij minus ui plus bj, and for optimization, for optimum, the condition is just z greater than is equal to 0. If for all the non-basic cells the value in the triangle is greater than is equal to 0, then you can come to the conclusion that you have reached to the optimum. Now check how we find out it. Then is there any blue? No, green only. Okay. Then how much? 4 minus 1. Cij means this is the cost Cij minus ui plus bj. This is plus 3. For this 3 minus 5, this is minus. And for this 4 minus 6, 4 cost minus ui plus bj, that is minus 2. And 2 minus 1, that is plus 1. 3 minus 1 plus 2. And 4 minus 6 means minus 2. In this way, you have to find out the net evaluations for all the cells. Now see, here all the net evaluation values are not greater than is equal to 0. Minus 2, minus 2, minus 2. In this way, the different cells, the negative value has come. But all the negative values are same. 3 minus 5, minus 2, 4 minus 6, minus 2, this is also same. That's why you can select any one. You can select any one. Okay? You can select any one for further process, further step. Now what you will do? That means you have not reached to the optimum. You should change your allocation. Your allocation is not the best allocation. You have to change it. How you change it? That means negative value indicates there is a scope to shift the quantities from these cells. So where will take the value? So as the net evaluation value minus 2 is same. If one is more, you should select the both negative one. But as it is same, that's why you can take any one, only considering the square cells that I've shown you. So you have to put the allocations to the negative or net evaluation cells by using just to get the space. Okay, 2600 I'm writing here. So where you will put? So in this place I put the artificial variables. In this case, as here is a scope, so you can put here also, or you can put the value here, here you can put also, here also, no problem, and here also. So I am checking with the help of, but you cannot put here. You cannot put this epsilon here. Actually, the concept is you have to bring the allocation here. So theta, but you should not take here the allocation because in that case it will be a square. So it is better you can shift this allocation to get the optimum value. So that's why I am shifting this value, say, instead of there, because you have a scope to put this allocation, smallest value is here in this place. And suppose I am writing this place as theta. Theta, this is minus theta, plus theta, and minus theta. So the concept is this is the difference, the smallest difference you will consider. Theta is equal to theta minus epsilon is equal to 0. You have to drop one cell and add one to one cell. That means the value of theta will be, you take the value of theta is equal to epsilon. That is in place of, in this place you have to put in this place. So I am writing the new epsilon here, or it is better I am going to show you in next table. Okay. That means you have to bring some allocation to this cell, as there is an advantage, there is a negative cost. That's why the new variable I have the value add is theta. If you add theta to make the balance this side minus theta, and again to make it balance plus theta, and again this is minus theta. In this way you have make it balance. Then what will be the value of theta? You will always take the minimum difference values and put is equal to 0, because one you have to drop it. That's why you have to make epsilon minus theta is equal to 0. That's why theta is equal to epsilon. So I am going to form the new basic cells. So I am erasing this part to get space, or getting the space, because I have minimum space here. So that's why I am erasing on this. It is not required further. So I am trying 3 by 4 matrix. 3 by 4, 3 by 4 matrix. Okay. 3, 1, 2, 3, 4, 1, 2, 3, 4. The cost 2, 2, 2, 4. 4, 6, 4, 3. 4, 6, 4, 3. 4, 6, 4, 3. And 3, 2, 1, 0. 3, 2, 1, 0. And the allocation is, as epsilon is very negligible, then if you add epsilon with 100, it will remain 100. It is the allocation. Okay. Then the value will not change because it is in micro value. 100, the concept is 100. Sorry, this is 900. 900, 100, 900, 100, and that will be equal to 0. It will be dropped. And 700, 700, 700, 700, and theta 4, which is epsilon. the value of theta will be epsilon, and this is 500, this is 500, 500 and 400, 400 in this way. Okay. Now again we have to proceed for body. This is, you can, next table, say table whatever the number is this. So before starting to apply body, you again check n plus n minus 1. That means 3 row, 4 column and minus 1. That is 6 allocations are there. 1, 2, 3, 4, 5, 6. No problem. We can proceed to solve it. Achha, where we put 0? You always try to put 0 against the maximum number of allocations. But it is a case where the allocations row wise, column wise, everywhere is maximum 2. That's why I am taking to anyone 0. Starting point 0, and this is 2. The process is same, and the process is same. 2, 0, 2 minus 0 is 2. 2 minus 0, 2 in this way. So that if you add this, then you get this. Next, we have to find out all this. Okay. So I am not writing again. This is V1, this is V2 in this way. The similar process. This is U1 like that. So with the help of this 6 minus 2. 6 minus 2 is 4. This is U2. And you have to find out this, and this. How we find out this? With the help of basic cells. 4 minus 4 is 0. 4 minus 4 is 0. It is V3. And again 4 minus 4 with the help of this. If you add 4 plus 0, you get 4. Now this is also basic cell. You have to find out this and this also. So 1 minus 0. 1 minus 0 is 1. 1 minus 0 is 1. That is U3. If you add this plus this, you will get this. And 0 minus 1 is minus 1. That is, this is equal to V4. In this way, you have to find out all the dual variables U1, U2, U3, V1, V2, V3, V4. So that if you add the dual variables, then you will get the cost of the basic cells. You can check it 0. This is 0 plus 2 is 2. I will check 1. This is 0 plus 1 and 1. 4, say this is basic cell. 0 plus 4 is this way. The same process you have to do again here. Circle I am putting all the non-basic cell. And these are the non-basic cell. In the non-basic cell in this way. And how you will fill up this? This is actually UI plus Vj. That's why for this UI plus Vj, this is 0 minus 1. 0 minus 1 is minus 1. You write inside this minus 1. In this case, 0 plus 0. 0 plus 0 is 0. In this case, 4 plus 2. 4 plus Vy plus Vj, 6. In this case, 1 plus 2. This is 3. And this is 2 plus 1. 2 plus 1. This is 3. 2 plus 1 is 3. And this is minus 1 plus 4. This is, in this way, you have to fill all the circle in this way. You can check it so that it should not mistake. Any 0 plus 0 is 0. 2 plus 4, 6 is 0. And finally, you have to find out the value of triangles. Triangles here. This is a triangle. This is triangle. This is a triangle. This is a triangle. This is a triangle or non-basic cell. And you have to find out the value of Cij. Z, this is equal to Cij minus Ui plus Vj in this way. In that case, 2 minus 0, that is 2. 2. In this 4 minus 6 minus 2. 4 minus 6 minus 2. Non-basic cell. 3 minus 3, that is equal to 4. 3 minus 3, let 0. 3 minus 3. 3 minus 3 is 0. And 2 minus 3, that is minus 1. 3 minus 3 is 0. I think I have completed all the triangles. The here again, Cij minus Ui plus not greater than is equal to 0. That means you have not reached to the optimum. You have to proceed further. You have to proceed further. But which cell you will select? Which cell you will select for allocation? You have to select this one. You have to select this one. And this is the most. This is the most negative. You have to select this one. That means theta you have to put here. You have to put allocations in this cell to make it balanced. This is you have to do in this way, plus theta and minus theta. If you add it, there is no change. If you add it, there is no change in this way. Epsilon remains in that same place. Again, to save the space, I am erasing this matrix. I am showing the, I am just noting this value 600, 700, because for the final table, you will check that value must be lower than this or at least 7. For every stage you can check it, either it will be decreased or same in this way. Now I am erasing this matrix. After this matrix, I'll go in this place. That's why I'm erasing. This is a big problem, I think, longer problem. Sometimes it may be, but you are moving methodically. That's why there is no chance that you will not reach to the best one or optimal one. I think in this level it will be solved. I think, I don't know, only after doing. And now I am doing slightly faster. It is 3 by 4. The process is same. That's why if you understand one process, it will no problem for you to go further. So 3 by 4 matrix. 3 by 4, 1, 2, 3 by 4. 1, 2, 3 and 4. Triple to 4. Triple to 4. 2, 2, 2 and 4. 4, 6, 4, 3. 4, 6, 4 and 3. Very careful to note down the figures, otherwise you will be in trouble and it will repeat the same process again and again, and ultimately you will be to the wrong conclusion. This is the matrix, okay, and the allocations are, you have to put the value of theta. What value out of this negative? You take always the lowest one. This is the lowest one. Is equal to 0. That means theta is equal to 700. That means you put theta is equal to 700 to the next level. So 700 theta is equal to 700 means 200. 200 this, and next is 700 plus 100, that is 800. 800. This is 700. This is 700. 700. This and this is 0. 700 minus 700, that will be dropped and it will be included. Epsilon remains there. 4 epsilon will be remains in the same place. 500, 400, 500, 500 and 400. Okay, probably I have written down. So in this way, the revised matrix will form. Now again, you have to apply the modi, and before applying it, you check the number of allocations must be m plus 1, m plus n minus 1, that is 6. 1, 2, 3, 4, 5, 6. And for that you can proceed. If again it is dropped, say 5, again you have to add artificial variables. It may be epsilon or epsilon 2. As many number of artificial allocations are required, you have to put to go ahead so that m plus n minus 1 is satisfied. Now again the same process you will repeat to find out the u and v. Is there any maximum number of allocations? No, everywhere it is same. That's why I am taking as it is 0. So that's why it is 2. I'm not writing in detail. 2, 2. So with the help of basic cells, 4 minus 2 is 2, and basic cell is 4. With the help of this 4 minus 2 is 2, and you can check. You will get all the dual variables. 1 minus 2 is minus 1, and 0 minus 1 is plus 1. This is u1, this is u2, this is u3. The dual variable. This is v1, this is v2, this is v3, and this is v4. By forming the equations to find out the variables, it will take a lot of time. That's why I am doing directly. Okay. Now, what you have to do? You have to find out the value of the circles. I am not going to note down it again in detail. I am not going to note down the detail of the process. I have several times discussed it. Only the same process I am repeating for all the non-basic cells. Just to break the process slightly faster, I am writing 1 plus 0, this is plus 1, and this is 1 plus 2, this is 3, 2 plus 0, this is 2, and 2 plus 2, this is 4, this is 2 plus 2, again sorry, this is 2 plus minus 1, that is plus 1, not basic cells for this is 2 minus 1, this is plus 1. Probably in this case we will get all the net evaluations values greater than or equal to 0. Now you have to find out the value of the triangles to check whether you have reached to the optimum or not. For that I am writing the triangles for all the non-basic cells or triangles in this way. And what is the value of the triangles? 4, net area 4 minus 1 is 3. This is 3. This is 2 minus 2 is 0. 6 minus 4 is plus 2. 3 minus 1 is plus 2. And 2 minus 1 is plus 1. That means Z is equal to Cij minus Ui plus Vj greater than is equal to 0 is satisfied. All these are the net evaluation cells. All these are, this is 0. That's why you have reached to the optima. This is the best allocations for which the total cost will be minimum. You can check the total cost for this cell also, but I have not noted. Okay. The total cost will be, in this case, how much will be? This is the best allocation, 200. You can check. This will be either the same value or lower than this. 200 plus 2 plus 800 plus 2. Now 700 plus 4, 700 plus 4 plus 700 plus 4. This is actually a negligible quantity. That's why you can assume that it's 0. We are not considering it as this is very negligible quantity. 500 into 1, 500 into 1 plus 400 into 0. 400 into 0. Now check what is the total cost. I'm going to check it. That is 400 plus 1600 plus 2800 plus 500 and 5300. 5300. This value is 5300. That means this is lower than this. That means this is the maximum possible minimization. And if you change any allocation, the cost will be higher. And this is the advantage for modeling method. If you move step by step, then finally you will reach to the best solution where the cost will be minimum. But this is not our solution. Our solution is maximization. That means you have to go to the original profit table. That means your answer will be the maximum profit. Maximum profit will be how much? Maximum profit, this will be your application. That means this is the best allocation. That means this is if it is A, B, and C. 1, 2, 3, and 4. The best allocation is you have to shift from factory A to the dealer 1 200 units. You have to shift from factory A to dealer 2 800 units. In this way, you have to shift from factory C to the dealer 3 500 units. Then profit will be how much? This is not the profit figure. The profit figure is how much it is? 6, because at the starting point you subtract from the maximum 8 minus 2 is 8 minus 6. That is then comes 2. That's why this is equivalent to 6. That is, you check the original table. 200 into 6 plus your profit will be 800 into 6 plus 700 into 4, because after subtracting you have got 4. Okay. Then next allocation you will not consider it as it is a negligible quantity. Next, and this will be how much? You have subtracted. Sorry. You have to go to the first table and see what is the profit. Okay. That is okay. 200 into cost. Actually, after subtracting, it was right. Okay. That is the problem. 6. Because after subtracting, you can check from the problem. 800 into 6 plus next 4. 700 into 4 plus next epsilon will not consider, and 500 plus 500 into 7, because out of, if it was 7 only, then it was that is 7, and plus 400 into 8. This will be the maximum profit. And how much it is? You can check. 1200 okay, so also, and then also. plus 2800, sorry, 1200 plus 4800 plus 2800 plus 3500 plus 3200 minimum 15,500 rupees. That is your answer. The maximum profit will be this. Then what will be your answer? Your answer, this is the best allocation. That means you have to shift from factory A to dealer 1 200 units, from factory A to dealer 2 800 units, from factory B to dealer 1 700 units, and from factory C to dealer 3 500 units, and from C factory to dealer 4 400 units. And you can check that the availability and requirements will be same from the original problem, and this is the final figure, how much profit you will get. This is the profit amount. This is the solution of a metric of a maximization problem in transportation. Okay, if you have any doubt, because it is a slightly lengthy problem, you please write to the comment box. I will definitely answer it. Again, I am just briefing how I have solved it. First of all, in the case of maximization problem, you convert the problem to minimization. How we convert it? You find the maximum element of the profit element from the matrix and subtract all the elements from that maximum element. Then you will convert the maximization problem to minimization problem, as it's equivalent to opportunity cost. You are losing the opportunity cost. The minimization of cost means maximization of profit. In that way, we will solve it. And after that, we will find out the basic feasible solution. In this case, I have taken the matrix minimum method. You can also apply any method, and after that, you will apply the MODI method. At the time of when you will start application of MODI, you always first check that the total number of allocation should be m plus n minus 1, where m is the number of rows, n is the number of columns. And if it is not, if it is less than m plus n minus 1, we have to add artificially one variable and value, that is called artificial negligent quantity. In this case, epsilon I have selected, and we should proceed. And then you will apply the bifurcation of the basic cell cost into two parts, the two variables, into dual variables UV, and finally I have already shown how we proceed and finally reached to the conclusion and optimization. And this is the index for finding you have reached to the optimum best solution or not for net evaluation Cij minus Ui plus Vj for all non-basic cells must be greater than 0 to 0. When you will get this, that means you have reached to the optimum. Thank you very much. I think you will be benefited by this problem, and if you like this, if you satisfy you, if you are satisfied, then please put a like to motivate to move for further. And if you have any further suggestions to solve any other problem, you can mention in the comment box. Thank you very much.